Hi everyone. In the second part of the video, and actually the 8th one that I'm making right now, I'm going to show you how to design an axle to fix this wheel onto these chassis. So if you wait up and see, let's go ahead and make this part not as visible once again. Wireframe. We have right up till here, we're going to have a part. Right up till here, we are going to have the axle be 8 millimeters thick. From here to here, it's going to be around 10 millimeters thick, and then again it's going to become 8. So let's go ahead and try to design the axles. First, let's measure the distance between the two parts that would have to be of the length that we desired, 27 millimeters. So let's make a new part. And as you know, an axle can be easily made by rotating. For some reason this is not working well. Top plane, let's 0, a little higher, and yes. We want this to be 27 divided by 2 millimeters. We want this to be 8. We want this to be 10. And say we want this to be, I don't know, 25. Actually, let's get rid of that. And drawing something else like this. Let's say we want, of course, we want these to be equal. We want this and this to be equal as well. And let's say that one place is a little shorter, and say this needs to be 20. This moves around, so just to make it look all black, let's do that. Let's make this vertical to that. Now this is fully defined, and now we can revolve this around this axis, and we have a very crude axis. This is just very, very crude, but axle, not axis. But let's go ahead and insert this. Concentric. Oh, common mistake. Since we are rotating this has to be 4. And we have to go and change this as well. This has to be 8. No, that's not 8, that has to be 5. Like this. Now that looks better. Let's go ahead and mate these two. And you can very easily see that once we put these parts in and bolt them, this is not going to get out. So that inside part we are done caring about. So and since we don't have to look at the inside anymore, let's make the component display shaded with edges. And now what's up to us is we have to vary the length of this axle to put it in the desired positions that we want it to be at. For example, here and here. We want this axle to be at the edge, so let's see around how long this has to be to get there. Normal distance is about 50 millimeters. And say let's make this 50. If we want this to be around here, that axle needs to come out a little bit more. That's 2, so let's make the 3. Let's increase the length by 3, 53. And what we're going to do when we make this axle is we're going to make a tap hole. So right on this edge, we're going to drill a hole that you can bolt something in. Say on M3 or 6-32 hole, both of them would be fine. And after making that hole, you can use a random plate to screw it up over here so that this does not move. I'm going to show you how in a very short amount of time. Let's make this 3.7. Make a tap hole for say 5 millimeters inside. Now we have a hole over here. Make this coincidence. And you can use anything, say like, okay, I'm going to try using say a TETRIX part because that's something that we have very rarely. Not an angle, say a bar. Say you have this bar, a random bar walking around. And what you can later do is you can drill a few holes on this bar on other places. No, actually it might be just better to show you how to make a new part. Just make a new part. Let's insert a new part on this plane. It's going to be centered on here. It's going to get up till there. The distance will be say 10. And let's say I want this point to be coincidence with that as well. Now this is defined. Let's make 3 holes. Extrude that for 3 mils. Now after this, you can just bolt this here. So bolt the axle in with this plate, and bolt the plate onto this side. And now your axle will not be able to move from this side, and you can do the same thing to the other side. For example, right now, what's the distance between this and this? The distance is 23, and we know that it's going to be a very clean number because we took time and effort to make the inside length very clean, and the TETRIX hole patterns TETRIX hole patterns have clean numbers inside. So make that 48. Now this will be at right there perfectly. Let's make that tap hole once again. So I want to sketch there a hole. And then cut extrude for 5 mils. cut, extrude. Okay. I went to the wrong place for some reason. I want to edit this component. So let's edit that component. Sketch there. A circle. That is 3.7. Cut, extrude. 5 mils. Boom. We have that. And we can just go ahead and copy that part like this. Let's go into the make menu. Here and here. Here. And here. Then here. And here as well. And now you can very easily see that this is not going to move side by side. It's going to rotate very prettily. And since we have ball bearings, it's going to be a very smooth rotation as well. So now if we go ahead and see the different parts that we made for this, we will need 2 of these, 1 of that, 2 of these plates, and 1 axle. These parts are the parts that we need to manufacture in order to use this for 1 wheel. And honestly, I do think that this is a much better simplification compared to the one that we had before using all those different TETRIX kits. Let's go look at it once again. Look at how complicated this is with so many different parts, and this is not even finished. It doesn't have a ball bearing, so it's not going to rotate that smoothly. And you also know that the TETRIX axles are infamous for breaking under pressure. And this is a much cleaner, simpler way of connecting a wheel to a body. And I think that even if people are not using these Meccano wheels, for any kind of wheel, this is a very, very good approach to make whatever thing you're making have better wheels, and for the wheels to be much stronger for the wheels to be a lot stronger when you are putting them under pressure. If you want to make these parts, however, you'll have to save them in a different pattern. So let's go ahead and save the parts externally so that we can access them outside. So let's save this part in an external file, same as assembly. Let's go save this. Let's go and save this as well. Save part in external file. Now let's make a new assembly. All these are parts that we need, and also remember we'll be face milling it, so make sure that this side faces the top. When you're actually doing it, you will have to make, say, if you want 4, you'll have to make 4 copies of this. Say 1, 2, 3, 4, and then put them in good positions to send them. But for now, let's say we need just this set. What we have to do is you have to save it as a different kind of file so that the people in the manufacturing centers can just go ahead with their work. We have to save it as first a part. You save it as a part first. This may not sound intuitive, but please wait a little bit. Now that you saved it as a part, you can open it, and now you can save it. It's a drawing file, .dwg. This. And let's do that again. Wrong click. Drawing file. Say we all want to print these out in 3D. So before doing anything, you have to do this and then save it as a drawing file, because you want to export it in the direction that you're looking at so that it looks correct. Current. And this is what it will look like. Press yes. No, I don't really need to save that for now. And let's go ahead and then open this up. Drawing files are native to AutoCAD files, and since these are two-dimensional parts, they can easily be manufactured on a 2.5 dimensional CNC simple table milling machine. Inventor usually takes a very long time to open up. Let's wait a little for the inventor. So we know inventor's coming up. Let's wait a little bit more. Yes. So inventory is here right now, and you can easily end up using this. Sometimes something that you may want to check is seeing if this measures correctly. Sometimes if the dimensions that you export this is wrong, it's not going to show correctly on Inventor or Autodesk, which is a problem when you're actually trying to manufacture something. That is the end for today. This, I hope, is a method that you find very useful when you are connecting a wheel onto a base. But also, this is just a very simple exercise on how you can simplify axle lengths by face milling different parts, so that the people, whether it be you or the people or the person making it for you, can have an easier time making the entire thing. Thank you very much.